Hello students, greetings to you all. Hope you all are safe and doing good. Welcome you all to our science class. So let's move on to the motivational quote for the week. Shoot for the moon, even if you miss, you will land among the stars, said by Les Brown. I repeat it, shoot for the moon, even if you miss, you will land among the stars. Yes, my dear students, you are capable of more than you think. So here with this motivational quote, we'll move on to the recap session. In last two class, we were dealing with Unit 7, Atomic Structure. In last class, we saw about atomic number. So what is atomic number? Which is nothing but number of protons. Which is number of protons is equal to number of electrons. And to calculate mass number of protons plus number of neutrons gives mass number. And to find number of neutrons present, then mass number minus atomic number gives the neutron value. And the element is denoted by XAZ, where A is nothing but the mass number and Z is nothing but the atomic number and X is nothing but the element. Next we saw about valence shell and valence electron. What is valence shell? The outermost shell is called a valence shell and the electrons present in the valence shell is called as valence electrons. And what is meant by valency? Valency of an element is the combining capacity of an element with other elements and is equal to the number of electrons that take part in chemical reaction. Yes, so I hope you all understood previous two classes. The topics to be concentrated in this session are isotopes, isobars and isotones, law of chemical combination and quantum numbers. So let's move on to the class. We know that there are three subatomic particles of an atom, right? What are they? They are proton, neutron and electron. So now let me arise a question before you. Which subatomic particle identifies the atom? Whether it is electron or neutron or a proton. Let us examine each subatomic particle briefly. Here we are just going to see or check by adding one by one subatomic particles to an atom. So first we'll take the electron. We are going to add electron to an atom. Let's see it.
So here we have a hydrogen atom. A hydrogen atom has one proton in the nucleus and it has one electron. Now I add one more electron. So when I add one more electron to it, we see that it still remains hydrogen. The element remains the same, but since an electron is increased, so the total number of negative charges are more, that is, it becomes a charged species, so it becomes an ion. Since the number of negative charges is more, so it becomes a negatively charged ion. So when I increase an electron, it becomes a negatively charged ion, but it still remains hydrogen. That is, the element does not change, it only becomes a charged species.
Yes. So what we observed in this video, so by changing the number of electrons, the element does not change. And it only becomes charged species, which is a positive or a negative ion. The chemical properties of an element changes with the number of electrons in an atom. We know that electrons participate in chemical reactions. So if the number of electrons change, then chemical properties of an element too changes. So chemical properties of all the element depends on the number of electron in an atom. So now we are going to check the second subatomic particle, which is neutron. Now let's add neutron to an atom. Let us see what happens.
So again, we have a hydrogen atom. The nucleus has one proton and it has one electron. Now let me add one neutron to it. When I add one neutron to the nucleus, you see that it still remains a neutral atom. That is, we know that neutrons are neutral, they have no charge. So by increasing one neutron, the neutrality of the atom is not changed, it still remains neutral. The atom also remains the same, that is, it was a hydrogen atom. So now by changing the number of neutrons, if I add one more neutron to it, we see that it still remains hydrogen. That is, the element is not changing and it remains neutral. It becomes an
Yes. So what we observed in this video, by changing the number of neutrons, the element does not change. Yes. And it gives rise to isotope formation. And next one, by changing the number of neutron, the physical properties of an element changes. Physical property in sense like mass, all changes. Okay. Now we are going to check the third subatomic particle, which is proton. Now let us add proton to an atom.
So we have a hydrogen atom. The nucleus of the hydrogen atom has one proton and it has one electron in its shell. What happens if we increase the number of protons now? So now I add one proton to it. So you see that it's no longer hydrogen, it becomes helium. So by changing one proton, hydrogen changes to helium. What happens if I add one more proton now? It becomes lithium. So by changing the number of protons, the element no longer remains the same. It changes into another element.
Yes. So what we observed from this video now, so by changing the number of protons, the element changes. And we know that the atomic number of an element is nothing but the number of protons. So by changing the number of proton, the element changes. So the atomic number of each atom is unique. So now can you able to answer the question that which subatomic particle identifies the atom? Whether electron, neutron or proton? Yes, of course, it is proton. As we change the number of protons, the element changes. Now, as we just saw, when we change the number of neutrons, it gives rise to isotopes, right? So let's see what these isotopes are. So isotopes are the atoms of same element having the same atomic number but different mass number. As we know that atomic number is nothing but the number of protons and mass number is nothing but number of protons plus number of neutrons. Here only the neutron changes. Since number of proton is present in both the atomic number and mass number, but in mass number we are just adding number of neutrons. So if neutrons vary, then mass number varies, right? So here neutron alone changes. So let us take an example of isotopes of hydrogen. So these are the isotopes of hydrogen. So here hydrogen has one proton, deuterium has one proton and one neutron, tritium has one proton and two neutrons. Thus the neutron only change, thus there will be change in mass number. So isotopes are the atoms of same element. These are the atoms of hydrogen element. They are the atoms of same element but having the same atomic number but different mass number. This is because of change in the number of neutrons. So there are two types of isotopes. One is the stable isotope and other one is unstable isotope. The one which we saw isotopes of hydrogen is an example of stable isotope. And what would be the unstable isotope? The isotopes which are unstable as the result of the extra neutrons in the nuclei are radioactive and are called as radioisotopes. For example, uranium-235 and cobalt-60. Used in radiotherapy treatment, these elements are radioisotopes, which is and unstable isotopes. Yes. So now let us consider five elements. Okay, five elements like sulfur, potassium, calcium, chlorine, and argon. Okay. So now when you observe the mass numbers here, they are given mass number and atomic number. For sulfur it is 4016. For potassium it is 4019. And for calcium it is 4020, and for chlorine it is 4017, and for argon it is 4018. So when you examine the mass number alone, all the elements have same mass number, right, which is 40, but they have different atomic numbers because they differ in number of protons and electrons. So here we can say that the atoms of different element with different atomic number but with same mass number are known as isobars. So isobars is nothing but the atoms of different element with different atomic number but same mass number. Now we know that to find the number of neutrons present in the nuclei, we need to subtract mass number with atomic number, right? So number of neutrons is equal to mass number, which is A, minus atomic number Z. Now let us take two elements. One is a boron and a carbon. So number of neutron in boron and carbon, okay, we are going to find it. We know that for boron the mass number is 11 and the atomic number is 5. Whereas for carbon the mass number is 12 and atomic number is 6. So when we calculate the number of neutron present, we are going to substitute to this formula, which is mass number minus atomic number, which gives number of neutron, right? When you subtract it, we get 6 for both boron and carbon. So this pair of element, that is boron and carbon, has the same number of neutrons but different atomic number and different mass number. So we can conclude that the atoms of different element with different atomic number and different mass number but with same number of neutrons, then it can be called as isotones. So what is isotone? The atoms of different element with different atomic number and different mass number but with same number of neutrons is known as isotones. So now next we move on to the new topic, which is laws of chemical combination. Scientists all over the world had been trying to find out many methods for converting one substance into another. During their studies, they made certain generalizations and they are known as laws of chemical combination. They stated laws, namely law of conservation of mass, law of constant proportions, law of multiple proportions, law of reciprocal proportions, and finally a Gay-Lussac law of gaseous volumes. Out of these 5 laws, in class 8, you all would have studied the first 2 laws, which is law of conservation of mass and law of constant proportion. So let us see the definition and founder of the first 2 laws alone, and we can quickly move on to the other 3 laws briefly. So first one is the law of conservation of mass. This law was proposed by Anthony Laurent Lavoisier in 1789. So what he stated is, according to this law, the mass can neither be created nor destroyed in the chemical reaction. So this is the statement he gave. This is nothing but the mass can neither be created nor destroyed in the chemical reaction. The second law was law of constant proportion. This law was proposed by Joseph Louis Proust. It is also called as law of definite proportion. So according to this law, in a chemical compound, The elements are always present in definite proportion by mass. So these two laws you have already studied in class 8. So now we'll see the next three laws in detail. Listen to the next three laws, students. So the third law is law of multiple proportions. This law was proposed by John Dalton in 1804. Let us start with an example. So let us take carbon. When the carbon combines with oxygen to form two different oxides, namely a carbon monoxide and a carbon dioxide, then the ratio of the mass of oxygen in carbon monoxide and carbon dioxide for a fixed mass of carbon is 1:2. So this law states that when two elements A and B combine together to form more than one compound, then masses of A which separately combines with fixed mass of B are in simple ratio. So law of multiple proportions state that when two elements which is A and B combine together to form more than one compound, then mass of A which is separately combines with fixed mass of B are in simple ratio. Let's move on to the fourth law, which is reciprocal proportion. This law was proposed by Jeremiah Richer in 1792. Consider three elements, which is hydrogen here, oxygen and carbon. Hydrogen, oxygen and carbon. When hydrogen and oxygen combines, it gives H2O, that is water. When hydrogen and carbon combines, it gives CH4, which is methane. And when carbon and oxygen combines, it gives carbon dioxide, CO2. So now let us calculate the mass ratio between the two elements. Okay. So first, let us take one example. First example, CH4. Okay. The combining elements is carbon and hydrogen. Right. So here, carbon, the mass of carbon is 12 and the mass of hydrogen would be 1. But the mass of hydrogen in CH4 is 4, right? H4. So 4 into 1 gives 4. Okay, so the ratio of this will be 12:4. So let it be equation 1. Okay, now let us take the next combination, CO2, carbon dioxide. Okay, here the mass of carbon is 12. The combining element would be carbon and oxygen. The mass of carbon is 12. The mass of oxygen, we know it is 16, but in carbon dioxide we have 2 molecules of oxygen, so 2 into 16, which gives 32. Thus the ratio would be 12:32. Let us consider as second equation. So from first and second equation, 12 it is common, right? So we can write it as 4:32, or it can be further reduced and written as 1:8. Am I making it clear, students? So let us consider this as equation A. Now let us take the third combination, which is water, H2O. This is a water vapor, okay? It is a gaseous form. So when hydrogen and oxygen combines, then it gives H2O. So the combining element is hydrogen and oxygen. So here when we calculate the ratio mass of hydrogen and oxygen, we get 2:16. Since hydrogen has 2 molecules in H2O, so mass of hydrogen is 2 into 1, which gives 2, and mass of oxygen, we already know it is 16. So the ratio mass would be 2:16. Let us consider it to be a third equation. Okay. Now this third equation can be further written as 1:8. It is divisible by 2, right? So 1:8. Now here, so from A and B, the equation A and B, we can conclude that the ratio is the same, right? 1 is to 8 and 1 is to 8. So, law of reciprocal proportion states that if two different elements combine separately with the same weight of the third element, the ratios of the masses in which they do so are either the same or a simple multiple of the mass ratio in which they combine. This is what law of reciprocal proportion states. So now we move on to the last law, which is Gay-Lussac law of gaseous volume. This law was proposed by Joseph Louis, known as Gay-Lussac. So let us discuss it with an equation. So consider this equation: O2 plus 2H2 gives 2H2O. In this equation, if we say that there is one molecule of oxygen reacts with two molecules of hydrogen to give two molecules of water vapor, right? But earlier, there were no sophisticated machines to calculate the molecules of the substance. So earlier, they used to measure the substance in terms of volume. The first scientist came up with the idea is Gay-Lussac. So he observed and said one volume of oxygen reacts with two volumes of hydrogen to give two volumes of water vapor. This means we can say as 1 liter of oxygen reacts with 2 liter of hydrogen and gives 2 liter of water, right? Yes. So here we observe that the substance reacts with volumes. Thus it gives a ratio of 1 is to 2 is to 2, which is a simple whole number ratio. So the Gay-Lussac law states that whenever gas reacts together, the volumes of the reacting gases as well as the products bear a same simple whole number ratio, provided all the volumes are measured under similar conditions of temperature and pressure. I'll repeat it. Whenever gas reacts together, the volumes of the reacting gases as well as the products bear a simple whole number ratio, provided all the volumes are measured under similar conditions of temperature and pressure. This is what Gay-Lussac law of gaseous volume states. So these are the 5 laws of chemical combination. Now let me ask you a question. So mostly everyone would have ordered any items in online, right? For example, you would have ordered book or food in online. It asks few details about where to deliver it. So when you specify the location of your house, it asks for which country, state, district, town, and so on. Likewise, to define the properties of electron, there are 4 ways, which is called as 4 quantum numbers. Okay. So quantum number is nothing but the number which designate and distinguish various atomic orbitals and electrons present in an atom, which is called as quantum numbers. So there are 4 types of quantum numbers. They are, first one is principal quantum number, which is N, which is main energy level. Second one is the azimuthal quantum number, which deals with this L subshell. It is denoted by L and it just deals with the subshell or shape of an orbital. Third one is the magnetic quantum number. It is denoted by small m. And fourth one is the spin quantum number, which is denoted by small s. So in higher class, we'll be dealing with quantum numbers in detail. And that's it for today's class, my dear students. Let's just quickly recap what we learned in today's session. So we saw first one, isotopes. What are isotopes? Isotopes are the atoms of same element having the same atomic number but different mass number. And we saw isotones. What are isotones? Atoms of different element with different atomic number and different mass number but with same number of neutron, then it is isotone. Then we saw isobars. What is isobar? the atoms of different element with different atomic number but same mass number is known as isobars. Then we saw quantum numbers, right? So what is a quantum number? The numbers which designate and distinguish various atomic orbitals and electrons present in an atom is known as quantum number. And we saw laws of chemical combination, right? So we saw 5 laws. In that already you learned 2 laws in 8th standard, and we saw the next 3 laws, right? So first law is law of multiple proportion. When two elements A and B combine together to form more than one compound, then masses of A which separately combines with fixed mass of B are in simple ratio. And next law we saw law of reciprocal proportion, which is nothing but if two different elements combine separately with the same weight of the third element, the ratio of the masses in which they do so are either the same or a simple multiple of the mass ratio in which they combine. And in the last law is the Gay-Lussac law of gaseous volume, which is nothing but whenever gas reacts together, the volumes of the reacting gases as well as the products bear a simple whole number ratio provided all the volumes are measured under similar conditions of temperature and pressure. And that's it, my dear students. For your follow-up work, you just need to draw the model of the isotone pair of sodium and magnesium and aluminum and silicon. Draw this in classwork. Take a picture of it and upload it in Google Classroom. Thank you so much, students. Stay home, stay safe. God bless you.